Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. Whenever you log on to Netflix, you will find some recommendations for movies you would like to watch. Or whenever you open Amazon, you will find some recommendations for products you would like to buy. This is because there are recommendation systems in place which are built to provide recommendations to you for something that you may like. The thing that gets recommended to the users is called an item. So that item could be a product, a song, or a movie, and the entity that the item gets recommended to is the user. Now, building recommendation systems is a popular data science problem, and these recommendation systems are built using data that comes in two flavors. The first flavor is a user item interaction data. So let's say a user rates a movie 5 stars. That interaction is taken into account in creating recommendations. Or another flavor of the data is the content data, which is the features of users and items, and that doesn't take into account the interaction between users and items. So this particular episode is to talk about building recommendation systems using content of the data. So, what is content? So, let me give you an example. Let's say there is a user named Bill, and Bill likes animated films. So, this Bill's interest in animated films is a feature of user Bill. And let's say Toy Story is an item which is an animated film. So the genre of Toy Story, being an animated film, is a feature of the item Toy Story. Now, since the user feature interest in animation films and the feature of the item being an animated film, they match with each other, it is possible to recommend Toy Story to Bill, and it's possible that there could be an interaction between Bill and Toy Story. And this is how the content based recommendation systems are built. So, how do you numerically do this? So, if somehow you can create a numerical representation of features of users and numerical representations of features of items, then you have a feature matrix for users and feature matrix for items, and you can create a product of these two matrices to create a matrix of possible interactions between users and items. Now, think about it in this way, that this matrix of possible interactions is only possible if you know the features of users and items. If you don't know the features of users and items, and if you still want to predict a matrix of possible interactions, you can do it with model based recommendation system. This model based recommendation system is basically you will create a model of interactions between users and items, and this model is created by matrix factorization or singular value decomposition. There are going to be other episodes to talk very specifically about singular value decomposition or matrix factorization. I'm just going to give you a small bit of theory behind it. So let's say we have interaction data between users and items, and there are some cells in that interaction data which are empty. Like, for example, some users have not interacted with some items. Now, the recommendation systems that we build using the interaction data and interaction data only, we have talked about them in some other episode, like averaging method or collaborative filtering or clustering based recommendation methods. But can we predict the non-existing interactions with the available interactions that we have? And that's what singular value decomposition does. What it does is it factorizes or decomposes an already available interaction into features of users and features of items, and then rebuilds the interaction metrics using those features. Now think about it, the building the interaction metrics using the features is same as the content based recommendation system, where you create a numerical representation of features of users and features of items, and you build the interaction metrics. That that step is still the same. Coming up with features for users and items is different. In the content based recommendation system, you already know the features, which is Bill liking the animated film or Toy Story being an animated film. But in singular value decomposition, the features are calculated from the available past interactions. And then you build the interaction matrix again, where the empty cells also get filled for knowing or predicting a possible interaction between a user and an item, and that interaction did not exist before. Now, when you create features by decomposing an already available interaction, those features are not really known to you. Like, for example, if we have this interaction of Bill likes Toy Story, if we have this interaction, if we decompose the interaction, we may not necessarily know that Bill likes animated films or Toy Story is an animated film. But we will know, like, in some vague sense, Bill likes something similar to Toy Story, and Toy Story resides in some kind of space which Bill likes. And this vagueness is there, and that's why the features that are created by the singular value decomposition are called latent features. They don't exist. So there are two ways to build recommendation system, to summarize. One, using interaction data, which is completely empirical way, and then the second is using the features data or creating the latent features of users and items from the interaction matrix. And that's the logical way, or you basically try to remove the empirical nature of the problem and try to create a logic where you can predict the interactions, non-existing interactions between users and items. Thanks. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.